So in the first part of solving the first order linear differential equation, I discussed steps that can be applied in solving a first order linear differential equation. So we are going to solve this problem, and we're going to have this as assignment. So we're going to solve this. And how do we solve that? First, we must arrange the equation in the form this. So we must be able to achieve this. So how do we achieve this equation? We achieve the equation by, you see, look at the equation, you can see y prime. Y prime is the same thing as the y dt. Please take note. Y prime is the same thing as the y dt. But you see that there's a coefficient here, cos x, so we have to divide through by cos x to be able to achieve this on the board. So let's do that. Apart. Okay, and I can also see that p of, okay, let's do that. We divide through by cos x, we are going to have y prime plus sine x over cos x, and that's going to give us tan x y. Take note that these are not products, equals to 2 cos square x sine x minus 1 over sine x, which is going to be sec x. I hope you know all this. Please always check my videos to understand all this. So if I divide this equation through by cos x, I'm going to have this, I'm going to have cos cube x over cos x is going to give us cos square x, and we have sine x. Then 1 over cos x is actually sec x. Okay, now we now have this form. So we have this form, so let's solve very fast. Since we now have this form, we now identify that our p of t, in this case p of x, in this case it's p of x. Just take note. So in this case our p of x, please take note, I'm replacing t for x for t here. So our p of x is actually tan x. So the next step there is for we to evaluate the integrating factor, and that will be I equals to e raised to the power of integral of tan x dx. So I'm not using t now again. So that is going to give us e raised to the power of integral of tan x is ln cos x is minus ln cos x. So integral of this is minus ln cos this. So you can always check that out. It's integration by quotient rule or so. The integral of tan x dx actually gives you this using integration by substitution. So that means this, we are on the right track. All right, so this will give me e raised to the power of ln 1 cos x raised to the power of minus 1. So that will be the same thing as cos x raised to the power of minus 1, which is the same thing as 1 over cos x. So this is going to be 1 over cos x, and that is going to be sec x. So you have that. Okay, so you have this cos x raised to the power of minus 1. So that's what we are using. So what we do with that is that, you see, this is the same thing as sec x. And that will be a little bit confusing, but review your logarithm. You see that a log ax is actually equals to x. So you can remind yourself of your logarithm, and you have that. I have a video on logarithm, you can check on that. So this is actually equals to this. So that means that our integrating factor is sec x. So we multiply all this with sec x. We multiply the whole equation with sec x. So we are going to have, so this is going to give us sec x y prime plus sec x tan x y equals to 2 cos square x sine x times sec x, and this is going to give us minus sec square x. So I'm multiplying the whole of this by the integrating factor. I'm actually doing this, the third step. I'm actually doing the third step, multiplying that by the integrating factor. That is going to give me, okay, at this point, what you do is you just go over to this, find the derivative, because this is actually, the left-hand side is actually the derivative. It's actually the derivative of y and the integrating factor. Very surprising, but that is true with respect to the x, and this is equals to the right hand side, and the right hand side is simply going to be, this is 1 over cos x. It's 1 over cos x, so we can cancel out this to have 2 cos x sine x minus sec square x. So what we do now is to integrate both sides. To solve for y of t, or y of x in this case, is to integrate both sides. So when we integrate both sides, we are going to be having y. If we integrate derivative, this is going to have y sec x equals to integral of all this. That is 2 cos x sine x dx minus integral of sec square x dx plus c. We will have y sec x on this other side of the equation, and here we have integral of this. This is simply, according to the trigonometric identity, 2 cos x and x is simply cos, so simply sine 2x. So take note, you can verify that. And integral of sec square x is actually tan x. That is quite interesting. So integral of sec square x is actually tan x. So integral of this is also going to be minus cos 2x all over 2. So take note, integral of sine 2x is actually minus cos 2x over 2 minus tan x plus c, and you have our final answer now to be y equals to minus cos 2x over 2 sec x minus tan x over sec x plus c over, I just make it very interesting. I make it very interesting by, I just have this. We just make it very interesting. We have minus cos 2x minus 2 tan x plus 2c, which is still a constant, so I will change that to k, all divided by 2 sec x. So that is like our answer here. So what we have is the general solution. So to go further, all we just need to do is to replace, for you to have the value of k here, all we need is to substitute pi over 2 for x. So x, put x as pi over 4, and put y as 3 root 2. So I'm not going to go that further. If you substitute that here, you're going to find the value of k. You can do that. You just substitute y here as 3 root 2, and substitute x here as pi over 4, which is 45 degrees. Once you do that, you can find the value of k, and then you have a final answer. So this is the approach to solving a first order linear equation. In the part 3 of this video, I'm going to solve a general form of a first order differential equation. Thank you. Bye.